Okay, all right, so we started.
Not like anything important is about to be said anyways. At least not I know.
All right, so guys, I'm going to be hosting today. Ken is off helping his son, and the others have other things to do. So we might see Jeff Martin in here at some point, who works on the Propeller tool. But it's going to be me and you guys. Okay, so welcome. It's like, what is this? August 17th, 2022, and this is the Propeller Live Forum. Oh, Ari is here. I wasn't expecting him.
Yeah, I just made it. Not sure if you can hear me, just to make sure that we had all the setup going.
Seems to be working.
Sounds good.
All right. One thing I wanted to discuss was the debugger. I've released it. I don't know if many of you guys have tried it. I know, where did he go? Francis has. I talked to him yesterday about it. There's some things I need to document about it, but I could just go over. I can go over this with you guys, and you'll get the feel for how it works. It's pretty simple, but I think there's some things that I need to document because I could see with Francis, it wasn't totally intuitive. I need to draw some diagrams to kind of show what parts do what. Let me share my screen here and I'll open this thing up. Let's see. Okay. Oops. Okay, let me see if I can just share part of my screen. That would be best. Let's see. Here we go. So I'm show a portion of my screen. Okay, where is that portion that I'm sharing? It looks like I'm sharing. You can see my whole screen probably, right?
Yes.
Okay, let me
Share a tall vertical window there.
Okay, advanced portion of screen, share. Okay, here we go. All right, so let me get this framed up here. Oh boy. Okay, sorry about all this. So here's, wait, it changed this sizing thing on me. Okay, so here's the debugger screen. I have here a little program. Let's see, let me go back to here. This is my source code. I've got two programs here. I've got debug messages mixed with actual debugger things. Let's see, we have here, you know what, this is not the program. Well, I'll just use this. Sorry, I didn't really prepare this very well. Let's see, where do I do a cog? Okay, so here I do a new cog, right? It's gonna run this program down here. I had it set up so I was doing some smart pin things, but that's off. So let's see, if I wanna see cog 1, oh, wait, I did a debug here. What have I got to do? Go. Oh, now it opens another one. Okay, so here's the program that is of interest. So for every cog that executes a debug, like, can you see my little cursor up here? Okay, if you insert that into your spin code or into your PASM code, when that is encountered during execution, it will throw up a window like this if it's not already open. If it is already open, it just updates this window. But this window is like updating perpetually. You can see the counter over here, always counting time. And these things over here are your breakpoint sensitivities. So you have this cognate option, which is independent of all the others. But the lower group down here, they are mutually exclusive with debug. So if I select main, and I can select all of these together, and then, whoops, but as soon as I select main or debug, the others shut off. So the reason I had to do it this way is I can't determine the difference between a debug breakpoint and a breakpoint from any of these other sources, with the exception of Cognate. I can tell Cognate because when I come into the debug interrupt, I have a flag that says this is an initialization. So I know that that's something different, but I had to do it this way so that you pick debug or one of these in exclusion to debug, because if debug is selected, then I can always look at the break code and know that, do I have like a breakpoint or do I have a debug message? Like you see down here in this window where it says test ABC equals, that's a debug message, right? Those things need to get through, but breakpoints are silent in this window. They don't show anything here. So these are sensitivities. I did say down here, like if I point to debug and as I move around, you can see things, the hint is changing in the bottom. I do say the debug is exclusive, but that's not maybe sufficient. I'm going to have to, and if you guys have any ideas on it, if this thing needs to be reformatted or presented in another way, I'd like to hear it, because I did it kind of in isolation and it turned out so that it works and does everything, but it's probably not the best layout. It's probably not the most, I think it's pretty ergonomic, but it may not be the most intuitive. So maybe we could fix it up with some hints, or maybe a change in the way we present all these things. But anyway, this selects your sensitivity. So if I select like main, it'll switch away from debug. And if I hit go, I can single step through things. And the window will kind of always scroll up. This is the disassembly pane, okay? If you go over to here, you can see anything like in the cog memory. And if I go back, I'm back to where I was. Same with the LUT or in the hub, or even I can fly around in here in this heat map of change and see everything. But when I come back here, it's in the mode that I left it. Now, if I go over to LUT and I say click it right here, it'll hold that. But if I click if I ever click the disassembly window, it goes back to where the PC is, because most of the time you're going to want to know where the PC is, right? But sometimes you might want to not be watching that, but watching some registers of interest, or maybe just observing something somewhere else in the hub. So as I fly around here, you see a lot of stuff happening in the disassembly window, but remember that when you go back to the disassembly window, or at least you're not in one of these types of things down here, it's going to be showing where you left it. So if I go here and I click on like byte 10, it'll lock the disassembly window to that. But if I click it again, it goes back to where the PC is. Now this, let me relaunch this so I can start from the beginning. You see this up here, it says reg delta. This is a list of changed registers. This is a list of changed smart pin readings, right? And this will automatically fill in, because every time it does a breakpoint, it gets all the cog registers, it gets the LUT, or at least it knows what it needs because of some checksums, and it reads all of the RQ pins, which are a non-interfering way to look at the smart pin values, the 32-bit values of each pin, without causing it to like, you know, be acknowledged and then release the in bit or something. So these are just places where changes will show up automatically, because it is such that if you're working normally, you know, if you just see the changes presented, it's going to be what you were going to be looking at anyway in most every case. So, but this, by making it smart like that, it hopefully gets around needing all kinds of like menus to specify what you want to look at and all this stuff, and just kind of automates it. And so if you come into a program fresh, it'll just show you what's matterful. You won't have to go and go, now what was that register? Let me go look at that. It'll just present changes. All right, so that's kind of an overview of this. If I hit go here, you know, if I left click it, it will single step. If I right click, it'll just start flying through here. Oh, and it just opened up another cog. But you can step from the very beginning of a program. Like if I say debug main, I'm going to uncomment this and run this. The first thing that pops up is cog0 running the interpreter, right? So this is the interpreter initialization code. And it's going to do a few things. So I'm already in main. Main will trap all of the cog init events automatically because you're going to single step every single thing that the cog goes through. So if I do this move 1d6, move 1d7, you can see up here it kind of filled in what the changes were. And then I do this next one. It's going to clear off some memory. Here it's going to, what is it doing here? Let's see. This is the cog initialization. You saw a whole bunch of, it just cleared off this space and loaded the interpreter into here. And then if I step a few more times there, it just cleared off the front part of LUT. And then the next time it's going to load in all this data that needs to sit in the LUT. And this was already here just because it was left over from something we did before. And eventually, if I just say go, it's going to run the spin code, which will eventually then open another window. Whoop, there it is. So now we have two of these things going. So this is the, so you see the first cog is just kind of automatically stepping. We're watching it. That's the one running spin. And then this other cog is just sitting here. It opened up at the beginning of its program, so I can tell it to go, or I can just say automate, and it'll run. Now, do you guys have any comments on this? Does this look like it's lacking in some way, or there's parts that are confusing? Do I need more pointers and things that alert you to what's happening? Because I don't think it's very complicated, but I need to make it so it's like an Apple product where you just use it and you don't need a manual.
Chip, I got a question.
Yeah.
As soon as it hits the debug and it pops open that screen for, let's say, cog0,
Mhm.
it's actually stopped, right? It's sitting there at a particular
Yes.
PC location and waiting for you to tell it to either single step or to run full as
Right.
fast as it can.
Right.
And that goes for the other debug windows that may pop up with further execution of the code.
Right. Yeah.
Okay.
Whenever it encounters, well, if you, okay, I'm here running this program, so I can stop it in single step. Now we do have a break. You see that thing right up there? So it's going to hit that as it loops. So I could say only run on debug. And as I run it, see, I'm clicking go, 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 go. So it's stopping after the break. Break 0 means assembly language breakpoint. And then it's showing me what changed since last time. So I can automate this. You're not seeing any animation in this window because it's the same thing every time, right? Just stopping at the same point after the break, but it's updating everything. So that's what happens when you put debug within a loop, is it'll report each time. But I could go like this. I could say stop on int1 entry, right? Which there isn't. There is no int1 entry. So now it's running full speed because nothing's causing it to break because I'm not using int1. So if I hit the break here, it stops and it was right here. It was at this instruction because it was ignoring debugs in that case. Oh, and Jeff, I don't know if you were here in the beginning, but I explained that I had to make debug sensitivity mutually exclusive to all these other things except for cognit, because we know when we come in on a debug interrupt after a cog initialization, or then we can detect that. But I cannot discriminate between, was that a debug we just hit, or was that a main instruction we just hit? So these things, so you can do all these things, right? But as soon as you select debug, it becomes exclusive. Although this is always separate because we can always detect that.
Okay, yes,
So-
I understand that.
So this way, if you have just debug sets, then it will, now I can run it again. It will only stop on debugs, but the nice thing is, if you have a message debug, it'll handle that as normal because the breakpoint debugs are #0. See this up here? And all message breaks are 1 through FF. They're like non-zero break codes. So break code 0 means go to the debugger. Anything else means do a debug message, like for, you know, animating plot windows and stuff like that. So that stuff will happen correctly when debug is set, but it will only stop on the these break zeros, like right here. You still there, Jeff?
Yes, I was just pondering something. So in between the breakpoint that actually effectively animates the screen for us, is it running like almost full speed, or is it running full speed?
Okay, well, right now it's running full speed between breaks, between debug. So this is really a debug right here. Break #0 is debug. So it's running full speed until it hits the debug or the break #0 again. And then it updates and then it runs again. But if I like tell it to note the value here, 068, right? So if I say just go on int3 entry and there's no int3, well, it realizes, hey, I'm not getting any breakpoints coming in anymore. I cannot update. All this information could be invalid. So I'm going to gray it out and give an opportunity to just do an asynchronous break. So when I hit asynchronous break, so you see the 068, now it's like 138. You know, it ran a lot during that time at full speed without interruption.
Okay, and is there anything that can prevent that asynchronous break from being effective?
Yes, you have to have another cog running, because you have to be able to communicate with someone to give to issue the break command for the cog you want to break. So if cog 1 is you know, not breaking and it's doing something and we want to get its attention, we need to have cog 0 like it is here. It's in a state where we're going to have opportunities to give it the break command. So we'll say, hey, here's a 8-bit mask, do breaks for all these cogs, and in course of running its little debug, it will scan through those 8 bits and then do a cog break, which is like an asynchronous break for everyone that had a bit set. So when we go down here, right, and this is kind of locked, we can't see anything because no breaks are occurring. When I hit break, it's going to tell this cog 0 up here it's going to have a 1-bit that represents this cog down here. And that thing, as it does its little breakpoint routine, it's going to send that mask out. And then this cog 0 up here, will issue the cog break instruction for this cog, and that will bring it back. So it looks like it all happened in the same cog, but actually you have to have some other cog open to do the work for you.
Okay, so the same is true if the situation were reversed here, where cog 1 is in a debug breaking in a loop.
Well, yeah,
but
watch.
cog 0 is frozen.
Yeah, so if we go here and I say break on int2, there is no int2, then now it's locked up. So now when I hit break, it's going to be cog 1 that issues the cog break, because see, if you go down here, you can see it's updating. It's getting, you know, many breakpoints per second. So when I say break here, it's going to have cog 1 do the job to free up cog 0.
I may have missed it there. Did you tell cog 1 to go full speed first before?
Oh, I just said int3, which there is no int3, right? So it's waiting for an entry to interrupt 3. Well, because interrupt 3 is not enabled, it's just nothing's happening. So it's running at full speed right now.
Yeah, but I think
if you get both waiting, it deadlocks, right?
We say that again.
I didn't see, was cog 1 running full
Oh yeah,
speed,
see,
or was it
cog
still?
1 is down here. Look.
Yeah, I see that now, but I just didn't see, was it still sitting at a breakpoint waiting for you to do something before you did what you did?
Well, as long as it's cycling through breakpoints, even though it's not stepping, it's getting updates, right? So this thing is like we're getting many breaks per second here. See how fast that thing's going?
Yes.
But because we're not stepping or doing anything, nothing's really changing. Right?
Right.
But I could do this. I could say, okay, this guy is in a break, right? And if I tell this guy int2 go, Now he's in a break. Now both of these guys are in a break situation. They both need an asynchronous breakpoint to snap out of it, right? Because they're both running full speed. None of them are getting, none of them are getting, or neither of them are getting any breakpoint anymore, because we're asking for something that's not happening. In cog 0, we're asking for an int3 entry, and cog 1, we're asking for int1. But because now neither of them are ever available, the break doesn't work, right? So we're now kind of
that's
locked
exactly,
out.
yeah, that's exactly what I wanted to know. Do we have to be careful about that as we're debugging, or will it just kind of happen naturally? And it looks like we have to make sure that we're not locking ourselves out of it.
Yeah, all you have to, I mean, and you just can reload if it blocks, but I mean, the only thing, you just can open a cog, just launch a spin cog with a repeat, it doesn't have to, it just has to be available. And if anything is like available, it can use that to reset the other cogs, or to break the other cogs.
So Chip, in this case, if we had a third cog available, then it would be able to resolve it, right?
Yeah, absolutely. Let's see. We'll do that now. I'll say, let's add another, let's do this twice, right? And then we'll run this. And I'll say, okay, I'll have this guy go. This is cog 0. He's eventually going to open cog 1 and then cog 2, or he'll launch. Oh, okay, there's another cog. And there's another cog. Now we got 3 cogs going, right? So if I say on this one, I say break on int3, go. He's locked up. Well, he's running full speed is what he's doing. So he's not available because there's no breakpoint occurring. And then we can do the same thing to this guy. He's locked up, right? But because this guy up here is still running, we can break this guy, no problem. We just hit break and it works now because someone else was communicating. Some other cog was routinely having breakpoints.
So it almost makes sense to have just one cog, if you can spare it, just sit there, do nothing, but
Right.
just give you the ability to break if you ever get caught in that weird situation.
Yeah, I mean, yes. So what would probably work out, it would work out like this. You'd probably just be running the debugger and then you go, oh, darn, I'm getting into a break condition, or I want to be able to run and do an asynchronous break. So I'll just launch another cog and just have it sit there. It doesn't have to do anything. It just has to be in like a repeat loop or whatever. And it had to have done it. It has to do a debug instruction of its own so that it has its debugger up and running. And then you have one available that can get you out of a bind.
So that other cog has to be running a loop that contains debug.
Yes.
But it doesn't have to be doing anything else.
It doesn't even have to be in a loop. It can just be stuck in a breakpoint. Because remember, when you get a debug, you run this thing. See, if I stop this here right now, right, it's still doing all kinds of breakpoints, right? It's just that the program counter is not changing because we're not actually running. We're just stalling and then reporting, updated information, and then waiting to see if the user clicked any button anywhere. And so this thing is stopped right now. It's not executing code. But it's ready. I mean, it could issue a cog break for another cog, even though it's not running, because it's sitting in the debugger and because it's routinely updating. It's available because every time this thing updates, that means it did a cycle, like a breakpoint cycle. Even though it didn't execute code, it just did a wait because we don't know what the user wants to do yet. He needs to go press a button or something. Does that all make sense?
Yeah, I think I understand. If you, let's say in this case, you started that third cog with just a debug somewhere near the top of its code, and then it went into a loop that did not contain debug, what would happen in that case? You wouldn't.
It would stop where the break instruction was, and it would just hang there just like this cog is doing right now.
Yeah.
It would be
And then if
waiting
you
for
told it
instruction.
if you told it to run full speed, and then it entered that little tight loop that had no debug in it, and then you went and set 2 unavailable ends for the other 2 cogs, then you'd be back to the same situation, right? Where
Right,
you're kind of locked out. Everything's running full speed, but you can't do anything.
right. Yeah, as long as
Okay,
you have
okay.
one guy. I mean, you just need to put one debug command in, and it'll go into this mode where it's waiting for some sort of input. And as long as you see it cycling like this, that means that it's doing all these breakpoint updates all the time. It's not running any code yet because you haven't told it to, but it's available, you know, and even if it is running, you know, I mean, as long as it's staying live and it's still getting updates, whether it's sitting on an instruction or it's looping or doing whatever, as long as it's having breakpoint updates, it can do the job of resetting or breaking another cog asynchronously.
Chip,
Yes,
do you hear me? Okay.
yes.
And if I have a cog that is running a loop so tight that it can't admit no type of debug or any other interruption. In fact, that cog is only producing data that is being forwarded to the hub and eventually to a shared LUT with the companion cog.
Yes.
Okay, that cog must not have any kind of interruption or disruption in its loop, but the other cogs can follow what is going on by following the hub, or in case of the companion cog, by following the hub or the LUT. I can do that, and that cog must not appear in one of the windows because it is not generating nothing sensible to the debug. All he does is through the hub or through the LUT. Can I do this into the system debug?
Okay, so what you're saying is you have a cog that you don't want to have it do a breakpoint because it's doing a lot of timing critical stuff, but you want
Yes.
you want to be able to watch its hub and IO pin activity.
Yes, because it's natural. Every other cog knows in what region the data that cog is gathering is put, and the companion cog can also look at the LUT, shared LUT, to see what is going on. And eventually that blocked cog that does not report anything can report, in fact, by means of the events, but only when he wants, only when he has time to do it. So no other cog can interrupt its job other than simply stopping it. If they want to stop receiving data, they can stop that cog. But otherwise, they must not interrupt its work.
So, okay, so let's see. You can certainly observe what it's doing to IO pins and to memory and hub memory.
Yes.
But if you don't want to, but you cannot. Okay, are you wondering, can you break it and just see where it is?
No, I must not break it.
Okay.
So it must never appear into one of the screens unless it's only the program itself as a means of looking at the listing, but not messing with its contents nor communicating with that cog. Any communication should be restricted to events or the hub contents, or the LUT, the shared LUT contents. You must not, or eventually you can set up a pin, and that cog will observe that the pin has changed and understand that it needs to stop, for example. This is a valid situation for that cog. But otherwise, the loop he is executing is so fast, so tightly coupled with the IO that it must not be interrupted in any sense. Thinking grabbing images from an ultra fast camera. I must, only to be in sync, I must never modify my synchronization with the camera. I need to stay in sync with the camera every time, or simply disconnect the camera. But while I'm doing the loop, I must not never be interrupted or otherwise is lowered.
Well, yeah, if your program is running and it's affecting the hub memory, you can use another cog to observe it. Like, see, let's see. This here is the cog running some spin2 program, right? This is the spin2 interpreter. It's on this top one. So it's probably causing this modification to occur down here. So if we look at this one, now this cog is just stuck. Like I can step it, right? But it's not doing anything right now. However, we're seeing on the heat map down here that something is changing here. So I clicked it and then look at that let's see, the FA, FB, FC, you see that? See how that's changing? Okay, now it's changing, but this cog's not doing it. The cog up here is doing it, right?
Yes.
So if we want to have this thing run full speed, I'll hit int 2, so it'll never break. Now as we go down here, now look, this other cog is observing. Look how fast it's changing now.
Yes. Okay.
So yeah, you can use other debug windows just for observance. And then the RQ pin thing, let's see. Oh, wait a minute. If we go here, if I right click, the read Q pin sensitivity is such that for a given cog, it starts out that you're only going to be possibly looking at changing RQ pin values that also have a DIR bit set, because those are smart pins that are, under control of this cog, right? So this cog doesn't have any that are changing, but if I go down here and I right click on this little window, it'll just show me all the smart pins that are changing. Even ones, outside of what I have DIR bit set to 1 for. So these are, now I click on that. Now we're seeing smart pin values changing that are not under control of this cog. Does that make sense?
Yes. All I want is that a cog can be, a cog or two eventually can be forgotten, in the sense they must not be touched, they must not be breaked, they must not, all interactions should be restricted to events or true values shared into mailboxes, into the pins, or into the hub, or between them through the LUTs. But never, no other cog can be looking at the cog at 1 or 2, because they are executing a task that is totally synced with sysclock.
Right.
Every sysclock will count.
So I think that happens naturally, right? Unless that cog has, unless you placed a debug in that camera cog, it would run full speed.
I understand. Okay, John.
Yeah,
okay.
if you don't put the debug in, but you know what? You could put a debug in. You could put a debug in just to let you have some initial view of it. But once you select something, and I guess I need to make some kind of thing that just says run until async, run, and then only an asynchronous break will get us out. So maybe I'll change this around. Maybe I'll move init over here and put like break up here or something, async, some word like that, so that we can have async means nothing, right?
Okay.
Yeah, I was going to pose that question, Chip. I'm glad you're bringing it up.
Yeah, so I'll change this to a 4-letter word, just init, which I have it in as over here. That'll mean cog init. It'll fit in this 4-column one. And then I'll put the word async over here, or BREAK. Yeah, maybe I'll just put BREAK and then init. And then we can, then you can actually select nothing as an active selection. So that when you hit go, it's going to run, and the only way you're getting out is to do an asynchronous break.
So, Enrique, quick question.
Oh, yes, please.
Your concern then is that you just want to make sure the debugger does not affect any other cogs other than the one it's running in, right?
No, in my case, it can affect every other cog, but one or two that I select to not be interrupted.
But I guess what I'm,
If
the
the
reason,
debug interrupts any other cogs, it's not my concern.
yes.
I must have, please, go ahead.
Yeah, my point in saying it that way, and correct me if I'm wrong, Chip, this is designed to not affect anything but the cog in which it was run.
Yeah, it's all,
Therefore, it already meets your requirement, I think is what I'm trying to say.
Okay.
yeah, see, every cog has its own conversation with the PC, and no cog is aware of any other cog's conversation with the PC. They only have to like wait for the resource to come up so they can own the TX and RX pin and the save buffer to get the debug program in and out of the cog. That's all they do, but they time share the serial port and the save buffer.
And on top of that, any cog or no cog has a conversation with the PC unless you instruct it to do so by putting a debug statement in.
Exactly. Yes.
Right.
We may want to be clarifying what PC means. Sometimes it means program counter, sometimes it means computer. That may be
The
confusing.
Windows
some
machine,
people.
yeah.
Oops, sorry about that. Host.
Yeah.
The host
PC,
machine.
Right.
program counter. Yeah. Oh, right. Right. I hear
Host
you.
on which the debugger the debugger interface is running. Chip, I'm seeing 3 different ways to invoke the debugger: the cognate, the main, and debug only, right?
Yeah. So the default is debug, right? So because the debug is the way any cog can say, hey, open a debugger for me. But
Okay. The reason for asking is I don't see the third one, debug only, in the documentation.
yeah, because that's the default. So
But can we call it out in the documentation? That
yeah. I need to add that. Yes, you have debug main, and you can also specify debug. These are mutually exclusive. Debug cognate. So
Right.
I mean, this just if you don't have either of these, it's only going to open the debugger on a debug instruction. If you put this in, it'll open it up on every instruction, even when the cog is initialized. If you just have this one, it'll only open the window on cognits.
I understand that. I was just checking up with the documentation because my syntax highlighting is driven by your documentation.
Oh yeah.
And so when I didn't see debug called out in there, debug without parentheses, I wouldn't know to do it.
Oh yeah. That's kind of a new addition. Yeah, debug without parentheses means a breakpoint.
Now, is there a reason you're using without parentheses versus parentheses?
And I just wanted the compiler. It's just a single word that if you don't compile with debug, everything gets ignored, right? All the debugs get ignored. I mean, I could have said debug and then in parentheses breakpoint, I guess, and had the compiler just make the break 0 instruction.
Or just an empty parentheses. The reason why is the parentheses are part of the decoding for the terms. And so if I have to put in 2 debug sensitivities, one without parentheses and one with, that's additional code for me, hence I have to do something new.
I mean, the thing is broken anyways.
Okay.
Right? like the thing with the single quotes is like giant headache anyways, right?
Oh, yeah, agreed. I'm just
Um,
trying to understand the reasoning.
Again, I think I figured out how to make it work without semantic highlighting.
Okay,
You really just need negative look ahead and recursive patterns to make it happen.
Yeah.
Recursive pattern in the negative look ahead.
correct. And I'll work with you on that. We'll get that working. All I'm saying is that it requires additional code in the extension. If you had empty parentheses, it would already highlight. Because you don't have empty parentheses, you have nothing. The debug keyword isn't recognized yet because I have to add a recognizer in there. That's all I'm saying.
Okay, so Stephen, it would take some extra work for you to have this Visual Code Studio stuff handle debug without parentheses. That's what you're saying.
Correct. If you had parentheses right now, it would already highlight.
Okay, I see what you're saying. Well, here's the thing though. It does mean though
I'm
that,
okay with doing it. I just need to know that you're doing it intentionally.
yeah,
and,
it was,
I'll go ahead and add it.
I didn't mean to make work for you. I just wanted to have like, because it's kind of like an argumentless, a operandless thing, just do a
Yeah.
breakpoint. I just made it like as simple as could be, just a straight word debug. So the customer never has to type anything either. He just puts debug in.
I mean, it would be very helpful if you could tell it to break only on a particular condition.
Okay, the trouble is we'd have to have a bunch of symbols that you would set up ahead of time in order to set those sensitivities up.
Right. Oh,
Like in my funny 68,000 emulation, I might want to break only if the PC equals to something, but not the actual PC, the virtual PC of the emulator.
Right. Okay. Well, here's the thing. We don't know that, right? Because that's all some implementation thing the user did. And all we know is our cog program counter at a certain address. That's as close as we can get. So
yeah, I mean, I could put a break in the instruction loop,
yes,
but I don't want it to stop every time because then it will. Then I have to click next like a million times.
Well, or yeah. What you would, in order to do that, you would have to say in assembly language, because all you write is in assembly language, right? You would say, let's see, if you'd get your condition is the PC equal to something, and then you would.
I mean, that's exactly what I do, but it's for printing out stuff, but it's like obnoxious.
Right.
If I can I share the screen? You can't. I can't share it when you are doing it.
Let's see.
I can show you the mess that's going on in my source code around the instruction loop.
Okay.
Do we have it? This one should be fine. There we go.
See, we do not know. We can't do a hardware breakpoint based on data context.
Yeah, of course not. Of course not.
Yeah.
I mean, you could technically, but it'd be complicated.
Yeah,
if you made a new.
doesn't support it.
That's what I mean. You could probably make it so it breaks if it writes to a particular RAM location, but you'd have to redo the silicon to do it.
Right.
Now,
is this Stephen's VCS thing?
yes, it is. Now check this out. This is all commented out because it's all debug code of different varieties that's sort of accumulated around this call to this function pointer. So this is mkgetOpf, which gets one word of program for the 68,000. So one possible one is the one up here. That's the usual one that compares the virtual PC to debug tripwire. And then there's a bunch of other things that you can uncomment here. Like maybe you want, there's another compare down here, which you have to be extra careful with because it increments the virtual PC in here. And then you've got the register print of various varieties. Sometimes you might want to print out every 10,000 instruction or something. The big problem here is that it adds quite a bit of code. So if I uncomment maybe this one and this one.
Right, and this is in your critical loop.
And this one, right? It inserts just this random branch in here and this compare. And actually, it would have to. That's not even how this works. This one will trip every time, but sometimes I only want to trip on the first time I go to a particular address, and that makes it even more complicated. There's a bunch of code paths here that I don't even remember that do stuff like that. Maybe I want to call to this function that doesn't even work anymore, called check core integrity. Wonderful things that does. So it would be very, I mean, it kind of has the if statement, like I can go debug if something. The problem with that is that something isn't an expression, something is a register, which has to be truthy or not truthy.
Well, see,
which is,
it would have to force a breakpoint, which would do an evaluation, which would determine whether or not we go into a full breakpoint, right?
yeah, that sort of thing, right?
That can be
I mean-
done. That can be done. It would, but here's the thing though. Anytime you do a breakpoint, we have to like wait for the semaphore to get hold of the serial port, right? We have the serial port pins and the save buffer in that top 16K of RAM. Those are things that only one cog can use at once. And so it would be like, you know, it would be many microseconds to do that. It wouldn't just be like in and out. Because it would have to like cache
I mean,
out.
my biggest problem with the if in the printing thing is that it still prints the cog number, even if you say if something blah. So
Yeah.
it still prints the cog number and maybe the thing that's kind of
Well-
obnoxious. I know why I can tell why it is like that from the code, but it's stupid.
Well, if you use the backtick, you can use that alternate syntax where you can just type stuff.
Does
you know
that work with the if?
The backtick.
Backtick. Okay, which button on this keyboard does backtick again? It's very obnoxious.
There it is, right there. Yeah. Now I think
No, it's
you
the
can
key
just-
next to the backspace, but you have to press shift, and it's also a dead key. So very epic.
Yes, that's a pain. Well, that is, let's see, if you read about the alternate stuff, you can just use backtick and you can just type text then. It makes it simpler. It's like kind of a shorthand version of the normal.
But doesn't it still print like a new line or something?
Debug will always make a new line, yes.
Yeah, I wanted to print nothing if the condition isn't set, and then I have to write like a branch around it, and that's the problem. That gets kind of ugly. I then have to delete it again, and then I want to debug the same thing again. I have to write it again. It's kind of a bit obnoxious.
Yeah.
But
Well, I don't know. Anyone have any ideas for Ada?
no, Ada, I think I'm sitting in the other camp with this one. While I understand your request to do conditionals in debug, losing control of the performance while the debug is being evaluated kind of works counterproductively for me in my mind. So having to write the code that is performant around the debug and not invoking the debug myself,
It's way faster.
yeah, I guess I'm kind of okay with that, to remove the need to coordinate the use of central resources for all the code.
I mean, yeah, if it's in something like this, I would probably still do that. It's just a good example of it, of something where you would want things. But often I put these things in like other spots, like that's the wrong one, but maybe I put it in something that is less important. Thank you for putting the thing in the outline, for making that work.
Good.
That is very good. Where is it?
What we're speaking to there is that single ticks now work to create outline instead of breaks.
Where is it? Mega VDP.io. I might put one into some function that only gets called a couple times a frame, like this DMA stuff here.
Right.
I mean, I think I can run it with this DMA logging enabled, and you barely even notice it because DMA is too fast anyways.
Right.
So in that case, I don't want to write the huge thing. And even then, this is hub exec, so it would be really slow if I did put the branch in.
Sure. Interesting.
Can you skip over a break instruction? That's a good question. I don't think you can skip over a break instruction. That's a good question. That's just because of the way that it works.
Are you saying put a conditional on debug, or do you?
No, I don't. Chip, this wouldn't work, right? If I went in and said skip 1 in front of debug, that wouldn't work, right?
Chip, that's a question for you.
Say it again. Sorry.
If I put a skip 1 in front of a debug, what does that do?
Yeah, that'll skip it. Oh, you know what? That's actually a very fast way to do the job, right? Well, it takes 4 clocks to do a branch, but I guess it takes 4 clocks to do a 2 clock skip and then skip over a debug.
Wait, the skip is not, well, this would take forever to branch because it's in hub exec.
No, there's no branching penalty, but so see, if you did a jump around, it would take 4 clocks, right?
No, it would take more because it's hub exec.
Oh, yeah. So for hub exec, this would be way more efficient. Yeah. And you can conditionally do that skip. Because the debug is always going to compile. In assembly language, the debug just becomes a break instruction. That's all it is. It's a single break instruction.
Wait, but why does skipping the break instruction work, but conditionalizing it doesn't work? Wouldn't that be the same issue?
Well, the debug cannot be conditionalized because things happen at different levels in the pipeline. Because a debug instruction has to stop things very quickly without letting the PC run another instruction, it gets detected in pipeline stage 0, whereas if you were to actually put a conditional in front of a debug instruction, all that would do.
Yeah, it's the standard thing, you know. I know we've talked a bit.
It would gate the writing of the break value. That's all it would do. I mean, the break code, because you have an 8-bit value, the break code.
But what makes the skip different?
Well, the skip doesn't flush the pipeline, right? It'll no-op any ensuing instruction that needed to be skipped. So if you say skip 1, it'll skip over that debug, which the debug instruction is really a break pound.
But isn't that already in the pipeline when it's starting the skip here?
Not yet. I don't think so. I see what you're saying. I don't think so, but you know, it'd be worth. I don't think so, but it might be. I don't know.
I think it is, but doesn't skip just no-op what's left in the pipeline?
Well, let me try it here. Let me put I'm going to have a loop in this little program. I'm going to say skip #1. Let me see here.
You have presentation control again if you want.
Okay, I'm just let's see. I'm just checking it here. So let's see if I go main.
Oh no, yet another edge case.
Wait a minute, why am I not? Oh, here we go. Okay, hold on. Stop. Oh, well, I need to skip. Here we go. Yeah, no, it seems to skip it okay. This is from the cog memory, not the hub, but that shouldn't make a difference though.
Yeah, do you have a regular skip or skip F? I guess if it's the next instruction, it doesn't matter, but.
It doesn't, well, skip F would be faster.
But skip F doesn't have the issue because it never enters the pipeline, right?
If you're in cog memory, yeah, it can skip, it can just jump the PC ahead without having to no-op things. But if you're in hub memory where you have the FIFO going, then it needs to no-op them as they pass by, because it can't like turn.
Yeah, I know the things. I know the things. I know too many things.
Yeah, so it's skipping the debug. So a skip #1 will skip the debug instruction because the debug instruction is just a single break instruction.
And that's true for both the debug that invokes the debugger and debug print statements.
Yes, in assembly language.
Yes.
Not in, well, yeah, in spin you can't skip. So yeah, so in assembly language, yes,
Okay, good.
it'll always work. So that's good.
In
to
spin,
know.
no one can hear you skip.
Right. In spin, no one can hear you skip. That's right.
Very clever.
Yeah. Yeah, that's a good idea. Use a skip and then you don't suffer the pipeline reload. And so you put your condition in there and then say if condition skip #1 and then do the debug. And that will skip it and it'll be about as efficient as it can be.
Well, that's cool. New hardware quirk unlocked.
Yes.
We leveled up our understanding here.
Now, if only we can find the 9th cock.
Yes.
Where did I leave that thing?
Jeff,
Yes.
I know you're busy with other stuff, but how soon do you think you can incorporate this in the Propeller tool?
Well, I can better say how soon I can get started on incorporating it. Because I know there were a couple of things related to serial that you and I had been talking about, which I'm not sure what effect that will have
Right.
on how Propeller Tool does it. But currently I'm working on a couple of things for education, hopefully before they become problems for our education efforts.
Right.
I'm kind of expecting that to take me into like the end of September. I might be able to start work on this prior to that, but you know, I can't predict how
Right.
fast
And
it will go.
I mean, really, this wouldn't be any big deal except for the fact that I'm now doing bi-directional serial, which complicates what's happening on your end with your code. Right? Because otherwise, this is just a
Yes.
window that my Delphi code opens up and, you know, your code wouldn't really care about that, right?
Right. Yeah. So all that stuff I think would be just kind of a slam dunk. All the handling of the debug screen and everything. It's just probably just the serial issues. And I think there was a timing related thing that you had talked about that hopefully that same technique that you used
Yeah.
would just apply naturally.
Yeah.
Sorry, I can't say for sure.
Yeah, that's fine. But okay, well, I'll have it ironed out.
Can you show another debug screen and then I've got a question.
Okay, let's see. Let me go back to share here. Okay, here we go.
So am I seeing, actually, let me ask this question. How, there's really just, there's 3 heat maps here, right?
Yes. Yes.
And
This is hub. This is all 512K of hub.
how does the display work in the heat map as far as persistence? Like if there was, go for it.
It fades away. After a change is noticed, it brightens up that pixel, and then it eventually fades to black. And
Okay,
then
it does.
Yeah, and then same thing over here. Like if I go, let's see, if I run this code here, you see it keeps modifying these down here.
Yes.
And so those are bright, right? They fade, but then they get refreshed. Now see, watch, if I stop the code, if I stop it, those things are going to eventually just fade back to normal. See that?
Okay, so, but up at the top of reg, for example, that's static code, right?
Yeah, so there's nothing changing. It's executing there, right? But it's not changing. But these registers are 100, 101. See, if I lock the display to this
Mhm.
and I say run, you can see how it's like wiping through there as it updates. But then if I stop, they'll eventually just fade away because no new changes are coming and they'll look like all the other data.
So if code either on purpose or inadvertently change registers that are within that, so-called static code, would that highlight bright yellow and then fade to what it currently looks like?
Oh yeah, it would do that. Like, let's see, let's go into our code here and say,
How does it know not to fade it to black?
well, it's just every time it gets one of these breakpoints, which can also just be like a wait and then update, wait and update. It's always getting new pictures of everything. So it's comparing the old pictures to the new pictures. And then when something changes, it keeps records of like, okay, well, how long ago did that happen? And then we run it down to eventually like plain, so all contrast, that highlighting is gone, but it's always just looking and paying attention and updating everything. So see this right here, right? If I say, let's see, what can we modify sensibly in here? Let's see, let me clean this up a little bit. Here's I made a little time domain reflectometry thing here using some smart pins. So here it's saying, oh, add to the same arrow. Why is it? Let's get rid of that. It's just junk. Now this is what we just proved out, right? We can skip one over the debug. Oh, set LUT sharing. That was just to turn on the indicator. We don't really need to see that. I guess we don't need this. Why do I have that there? Let's just keep this really simple, right? We're just going to modify these registers. So what I can do is we can say add see, we're gonna modify that add instruction just above. We're gonna modify the S field by saying this, and then we're gonna say and not. We'll constrain it to like, we'll add between 1 or 0 and 3, right? Or 0 and 7. So now when we run this, so what it's going to do is it's going to increment 100, but then it's going to start modifying this one value that exists in this instruction right here. So these two.
No, it will not do that. It will just set it to 0.
What's that?
It will just set the S field to 0.
Yes.
And then do nothing.
Yeah, the S bit, which makes up this one. Well, it'll add it, but then it will AND it with the not thing to keep. It'll just keep everything but the 3 LSBs the same. Wait, is that going to still roll over at some point? Yeah, at some point it's going to start.
No, that's not going to do anything. That's just going to set the S field to 0 and do that forever.
No, the S field is 9 bits, right?
Yeah, but if you add 1 to it and then immediately end it with 7, it just stays 0 forever.
It becomes 2.
No, it doesn't. It becomes 2 first, but then you end it with 7 and it becomes 0 again.
Yeah, it'll just cycle. But I'm thinking though.
No, it won't cycle. It will go 0, then it comes to loop. It sets it to 1.
I know what you're saying.
Then
okay, I know.
It doesn't work like that.
We need to do something like this. So it will let the LSBs, the 2 LSBs toggle, but it won't let the increment run up the chain and screw everything up.
Yeah, that would be correct.
Okay.
I guess you want 8.
Okay, 8, yeah. So it'll let it run from 0 to 7 now, and then it'll cancel out that rollover bit so it doesn't creep up into the higher order bits of the instruction. Okay, so
sometimes I just want an add that doesn't, where I can select which bits carry. That'd be useful.
Let's see. So
Don't you happen to have debug within that loop also?
okay, so here we are. Now we're gonna, if we go like this, we say go. Now, there it is looping now. Right? So it's, you can see up there that there's that line that's being highlighted.
Yeah.
In fact, if we just stay here, you can see it right there. See that? It's going 4, 5, 6, 7, 0, 1, 2, 3, 4, 5, 6, 7. And then over here, you can see that line being highlighted. I don't know if that shows up, but there's a line.
Yeah,
there
we can.
that's turning.
I can see it.
Yeah. So, and then if we stop, right, it'll slowly fade away back to the background colors.
Neat.
So it pulls your attention to where the action is. Like if we go down here, it says that there's something changing at one. Oh, this is in A and in B. These are changing, which are also seen right here.
Okay, thanks, Chip. I was asking all that because I figured you had it fading away, but I couldn't really see it happening in the code that we were using.
Yeah.
And a long time ago, I had written some code to sort of make the same type of display for a customer that was having trouble, that I suspected his code was inadvertently overwriting itself. And I used this heat map technique to prove that that was happening.
Oh, okay. Okay.
And all of a sudden his code blew up, but
Yeah.
but the other cog that I had this running in was showing, where the damage was.
Right. Yeah. So do you guys have any input on the general way this thing's working? Is there anything that could be improved, or is it not intuitive? Or
I mean, the obvious bug is that it's only in Peanut, and have fun getting anything to actually compile in Peanut. At least my stuff either uses has some sort of character that it doesn't like, or it uses flex spinisms that just won't work, period.
right. Oh, well, Ada, should I allow, what's happening in your case is it's seeing ASCII with the MSB set, and it's
Wait, but doesn't it know about Unicode?
no.
Oh, that's the prep. So it's just ignoring all the null characters that come in between, and it magically happens
Right.
that most of the code is right. But it sees the byte order mark, and it doesn't like that.
Right. Yeah.
I mean, the obvious thing is to just see if the byte order mark is there, then just turn it into ASCII, or just make the internal buffer Unicode, and then I don't know.
Well, you know
something
what,
along
Jeff?
that line.
Does Propeller tool handle Unicode?
Yeah.
I mean, yes, that's where it comes from.
Well, Jeff, you say yes, but the errors are completely off still.
Right. It's not allowing like European letters and things, right?
Well,
I would
of course
ask-
it allows European letters. Those are in the font ROM. It'd be terrible if it didn't.
So there's like, Stephen had found something that he pointed out, I believe, about how the errors, the pointer about exactly where the error occurred is off in the way that he used it. I think that's related to the way that the file, the way that the Propeller tool is handling end of lines on files, though. Is that right?
I don't know, but what I can tell you is this: my development environment on Windows machine, because I transfer all my files via Dropbox, is wonderfully entertaining in negative ways.
Yeah.
I basically line numbers are off in Prop Tool when there's errors. So whenever I have to track down the error, I have to fire up Peanut and compile. And then I get the real error message and where it is. And then I can track down the errors.
Yeah, I remember talking with you about that.
Right. And then secondly, both tools, Prop tool has an ability to compile the top object file without it being loaded into the editor, which then allows me to fake that it knows about the Dropbox file changes because I just compile the files externally that way. But if the file is loaded into the editor, it doesn't see a Dropbox file change. Same thing with Peanut. The files change outside of Peanut, and I have to reload the file before I can compile it. And so both are not being sensitive to file modifications external to the tool. And that's real painful as well.
Okay, got it.
Because
Have I talked about the thing where Prop tool sometimes stops saving?
Oh, Prop tool has a number of crashes with respect to saving and closing files.
I don't think I've ever had it like properly crash. Just by the sake of that it's when it gets an exception, it just gives you a dialog box and you can click it away and just goes on with whatever. That's kind of funny. It just ignores all the null pointer access. It just goes ahead. Very interesting. That's actually a good thing because often it's in a state that's good enough to save your work, and it has autosave anyways. Like it restores the files. It's actually good on that front. But sometimes it gets into a state where if you type stuff, it doesn't set the little star next to the file name, and if you try to hit save, it just doesn't do it. I think the obvious solution to that is to just always honor the Control S, even if it thinks that the file is already saved. That probably is the best way to just bypass the bug. But what do I know?
Okay, no, thanks. I wasn't aware that there was a situation like that where you could modify something and it wouldn't realize it, but I can make it certainly easily override that with just the Control S.
Yeah, that's a useful one. I think we already talked about the like million funny ways that you can break it when you type in Unicode that it doesn't know about. It knows about all the stuff that's in the character chart. Obviously, it would be terrible if it didn't. But if, yeah, we had the funny thing. I think if you type the paragraph sign, it just completely broke everything. And if you type the kanji, it would have like half of it or something. I think that was the state of things. Which, to be fair, handling dual space is a bit of a pain. And kind of pointless because the compiler will just explode it anyways. What was the other thing?
Chip, I put a note in the document, the Spin2 document, to remind you.
Thanks. Okay. Good. Let's see.
Chip,
Good question. What does Peanut do if you put a paragraph sign in it? Let's find out together.
You? You're raising without a
main debug lemao paragraph sign. What will we get? Node RAM debug. Yeah, I guess debug requires at least 10 megahertz of external clocking. I fucking love it. Set it to 200 megahertz because we can. It does nothing. Does it generate a space for it, or does it just ignore the fact that it's there?
Yeah, so that would be a bunch of stuff.
Yep,
You know,
it just ignores the paragraph sign. Cool. Now let's do the
it comes down
compiles.
to the compiler, though. I mean, Jeff is including my Spin2 compiler, which does not have any Unicode awareness.
Yeah, it just doesn't have any character set awareness. I don't think at all. It just thinks of bytes, right?
Here's the thing though. Well, one thing is that if we're sharing code with people all over the world, if we put in like European characters and all this, it becomes, they're not going to know what those things, those words mean anyway, right?
I mean, yeah, I think source code should be encoded in, you should not use any special characters in source code, just ASCII. And you should also not use them in file names, and you should just not use them in anything that isn't like prose.
Right.
Or like a comment, like if it's a comment or like a literal string, that's where you can use anything, but everything else should be, because this is a terrible issue when you have a file name that you can't like type into the terminal. That's terrible. If you have an identifier that you cannot easily type in a keyboard, of course you can always copy paste it, but then you have to go find it and like, or figure out how to type it, which is
right,
which will eventually, which in theory would eventually just lead to your language menu of all the installed languages, like taking up the entire screen.
okay. Well, you know, but you can put those characters in comments, no problem, right?
In comments, yeah, probably. I mean,
That'd be
the thing is,
place for that
the
kind of
Propeller tool the Propeller tool breaks at rendering, like stuff like the paragraph sign. So if you were to write code that implements like German law for some reason, like if, I don't know, traffic light controller or something stupid like that, then you couldn't do it in Propeller tool, because if you put a paragraph sign, it will completely destroy the entire syntax highlighting. But the other,
oh yeah, you've got all of Steven's stuff to worry about.
I mean, that works.
That would be a real like
no, the VS Code stuff just works with anything, because it's natively thinks in terms of Unicode.
Yeah.
And it like uses a really robust regular expression library. The normal syntax highlighting, at least, not sure what's going on with the semantic highlighter. But now let's take it up a notch for Peanut. What happens with the dreaded kanji test? Fucking nothing. Really? Just do nothing. Or did I just crash like the IME or something? Okay, cool thing about Peanut, if you have IME enabled, it just doesn't work at all. Utter bewilderment.
If you have what enabled?
IME, wait, it does show up, but it's just the thing where it shows up like at the top left of the top leftmost screen. So that's why I was confused. And of course, it just pastes in question marks. Which I think was the same thing that Propeller tool did. I think Propeller tool has the question marks when you. I think that's the same issue. Like that's the funny one. Does it have this? Yeah, Propeller tool has the extra funny issue. If you have an IME enabled and you're just typing normally, like something that it normally accepts, like if I type an umlaut normally into Propeller tool with the normal German layout, it makes the umlaut happen. If I switch to an IME layout, the umlaut turns into the unaccented letter. Let's see what Peanut does. I could show it to you on screen, but I have to disable conversion. And what does it do? Interesting, the same issue. Maybe I should show it. So check this out. Well, Chip would have to disable the screen share, I guess.
You want? Oh, okay? Hold on.
Want to see something? We can do the copy paste test afterwards, which is even more likely to not work. Why does it not? There we go. Welcome to the Peanut fun zone. So now we have the normal layout enabled. Type paragraph sign into it. It works. It does render. It does not break the syntax highlighting because there isn't any. Let's put an underscore after it so you can see what it's going to do. Load and do the thing. Save change, I guess, yes. And we'll just print LMAO space underscore. It just ignores the paragraph sign. Mental. Can you make this bigger? No, you can't. Oh, you can. It's just bizarro key combination. So this is what it gets. It just ignores that it's there. If I put umlaut, what will it do with umlaut?
Yeah, it's only using ASCII. It doesn't know about any of that.
Okay, it ignores umlaut as well, but what a shame. What if we enter something that would have to be a multi-byte character? As I previously exposited, if I switch to IME for Japanese and type in something, which I have to do in the top left of the screen because reasons, it does nothing except question marks. It's very cool. And if I now disable conversion and try to type an umlaut from just a normal keyboard, it just turns into an A. These are the things that happen when you go too high on something. So now I have to open up Notepad++ and type something in here. Typo? No, I have to hit space. I only use this to look up song lyrics. So sometimes I forget how it works. So here. Oh, no. It turns into garbage. That's bad.
Well, I wonder what those things are resolving to, because I'm reading everything in as 8-bit ASCII, and I don't.
I think you're doing something. I guess you're getting. What kind of bad is that even? It turns into 2 characters, but one of them might be just getting garbled out. Is there like a hidden character here? No, there isn't. That's weird. I don't think I've had that happen. I don't think I've had this sort of corruption happen from like clipboard pasting and anything yet. That's a new one. Like if you do it in Propeller tool, it will at least try to do something sensible. It will just give you half of the character, which is still terrible, quite honestly. There you go. We got exactly half a character if I do it in Propeller tool.
Yeah, interesting. I don't know what to do about this. This is like a whole thing that's complicated and.
I mean, I'm not expecting you to fix it. I'm just pointing out how broken it is.
Yeah. Yeah, I don't know what to do about that. It's a huge rat's nest.
I mean, what happens if I type Hebrew into the Propeller tool? I don't know how to type what the letters do for Hebrew, but okay. Yes, this is how Hebrew looks like. Certainly. It looks like Icelandic. Which I didn't know. I thought it looked different, but according to Propeller tool, it's Icelandic. Or wherever else this letter happens. Is okay. That's another one. What happens if I type in Russian?
All
okay,
right, well,
that's the same thing.
This is
interesting
situation that we're not going to solve anytime soon, probably, because this involves this is wide and deep, and I don't know. I don't think there are many I don't know if there are any halfway steps we can take to just sort of take what we have and accommodate somewhat these things.
I mean, it does already make because of the character table. If I set it to my
it has
normal thing, I mean, it has like the umlauts. I can type my name in without it exploding. That's a good thing. Even has the S, the best letter in the alphabet. I think there's another one on this keyboard that will make it explode. This one, it has this one. Which one does it not have? I think it's the forward tick. Yeah, the forward tick. It hates that. You're asking what is the forward tick? It's actually the one you get when you type the accent key, the accent dead key. Without shift, you get this forward tick, and that's also a character that Propeller tool really likes. Like, let's open something that we don't care about, like this here. Make it a bit less obnoxious. Like, oops, entire line has broken syntax highlighting, which is, I guess, good because you don't want this to exist in your source code probably, because it doesn't mean anything, but still, what a strangity. And I guess I said, if you wanted to say, what's the funny one? STGB, is it 300? Is it paragraph 307 now? I have to check. It actually breaks the comment highlighting. How strange.
All
Having
right.
the paragraph sign here makes the comment not detect. Bizarre. But not, was it 307? It was 317, probably. I'm going to look it up because that's a funny law. TGB 307, I think it was.
All right, well, we're not gonna solve this thing today. This is way too complicated.
Yeah, I said that I didn't expect it to. But
there are some, but there are
Paragraph 307 Strafgesetzbuch is the law in Germany that prevents you from making a nuclear explosion. Yes, we have a law against that. You can go to jail if you do it.
If you do what?
Cause a nuclear explosion.
Oh yeah, there are laws for everything.
You'd think that'd be kind of obvious or already covered by like normal laws that cover explosions.
And
But no, they have a special one for nuclear.
You're not allowed contact with extraterrestrials either.
Ah, that sort of thing. I don't think they have that. That'd be a bit funny.
We have laws about that, I think. At least we have signs that say that.
Yeah, around the area. Also, while I'm at it, I can show off the amazing. I have v1.0 release candidate 1 of both of the emulators. I can show it while I'm busy talking nonsense. I might as well do that. Where do we have the thing where I have to click the button to make the video happen?
Okay.
Check it out. 106 games in this compatibility list because we have to list them all because they all have a differently stupid memory layout.
Very cool.
That's amazing.
And you said you're marking in some way which ones are supported now?
I mean, yeah, this one's marked by which ones are supported. All the ones that are white are working. All the ones that are red don't work. And you find a yellow one, that's the ones that kind of work, but not really. This one again knows it because it has to have an internal database of every possible game.
Right.
There are more than 106 games, but these are just, I don't know, I'm too lazy to add any. I think I've got all the important ones. And again, we can now play games that no one has ever asked for. Like, again, Mahjong Q Resident. That's the credit screen, that's the wrong button. Check it out, how not it uses the memory. There's no English version for this, it's just fuck you if you don't know what a Mahjong is. But you have a character creator in an arcade Mahjong game for some reason. I've just pressed through it because I don't care. Again, this is the bottom of the barrel of games that no one asks for. But we can now play them on P2 because it works for the same reasons that the others do. I don't know how to play Mahjong. I don't know what it's saying. But it has funny music. Can we get to the actual thing? This is so silly.
That thing on top of that guy's head, the doorway, looked like one of those Chinese buns those guys would have.
Do you use dice for Mahjong? I guess.
Oh, this is a
Do-
mahjong game?
I mean, I said that at the beginning, yes. I'm not sure how you play this, because I don't know how this works, but
There are many ways to play that, I think.
yeah, I mean, there's like 50 different versions. There's like the solitaire version where you just remove pieces, but this is something else. I don't know what button I have to press. I think I've crashed it. No, I haven't. I can select something. Okay, two. These two. Okay. I have to...
All right.
Epic video game. But the music is funny. Because it's like half streamed. Like they stream the vocal part, but the other instrumentation is synthesized. That's kind of interesting.
Yeah.
Well, let's go to the other end of the spectrum. Where the music is still streaming because time is a flat circle. Load time. This is the power of the 96 megabyte board and the most shitty Neo PVC emulation that you've ever seen. Like Neo PVC is the sort of security chip that this uses, which technically has a bunch of features that you could check and like rely on, but they just don't use any of them. They just use the bank switch that it provides. Like mental, actually mental. I guess it may be used in the other games that have this, but this really just uses the bank switch register instead of, and I guess the fact that the ROM is kind of scrambled up, but we don't care about that. That's entirely transparent. The bank switch is funny because it doesn't just switch between like fixed banks. You actually tell it where to start in the ROM, and it can be any position in the ROM. I guess it has to be like by word aligned or long aligned or something. And they use that, so you know you can't just replace it with like a latch or something, which is what the normal bank switch boards just use. They just use a latch that gets latched when you write to the ROM region. Mm-hmm. This actually uses an actual register that lets you actually just select an arbitrary region. It does make use of that.
So you had to emulate that selection mechanism too?
Yeah, it's pretty simple. It just needed a special case for that.
Sure.
Also, the slide move in this game is atrocious if you've used to the other games, because it triggers when you don't want it to. You cannot get used to it, but I don't think this game was ever on Wii, so I'm not used to this one at all. Anyways, the power of the 96 megabyte board. I guess Ray has said he wants to like make it available to more than just a couple idiots. So myself included, of course. So maybe that will become an actual thing, because right now the only available actually RAM modules are like the Hyper RAM, the 16 megabyte one, the Parallax cells, and the P2 Edge that Parallax cells. Like that's the only ones. And those are like 16 megabyte and 32 megabyte each, which isn't enough for this nonsense. I feel like most of these games could be like half the size if they actually optimized the use of the memory, but they aren't. They are the way they are. Like, I don't think this really needs 8 megabytes of program, but that's not the main attraction anyways. I think a lot of these late games just have loads of unused graphics space because due to the ROM scrambler, they can only add it in 16 megabyte increments. So there's a bunch of late era small games that probably either just don't use all of the space or they just filled it with like guff because they had the space. And it actually is used, but like not for anything particularly sensible. So that's that basically.
And so
Do you have any-
the process for us wanting to use this then,
Is to just clone it off GitHub and then just make it happen.
and then we have to locate
Oh yeah, you have to locate the game ROM. If
okay.
you're not experienced, like I don't know. Wait, we're still recording. I can't talk about evil piracy. I will get sent to jail, and people will put me.
But you've
they'll-
got
I have to pick up the soap, but then they notice that the joke went nowhere. Please ignore the joke. It was bad.
do you have at least something that we can download and play that is open? Just
For the
to prove
Neo
that
Geo,
it's working.
for the Neo Geo, no, because you always need the BIOS ROM.
Okay.
That's if I load something small, you can kind of see it at the end that it loads. Do we have something that's really, really small? Oh yeah, we have up here. Load that at the end. It loads. Oh, I have still on. Yeah, I think I have it on. It loads a neo epo.bin, and that's the BIOS.
Okay. Okay.
And that's what makes the Neo Geo screen happen. And the game needs it because it kind of provides the structure for it to sit in.
Sure. Sure.
This is important for the MVS because the BIOS will also switch between different cartridge slots on an MVS multi-slot. And it has to know if you like playing the game, so it doesn't switch out the game while you're playing the game, which would be a bit shit. But it does want to switch out the game when you're not playing the game, so you can see all the games that are in it without having to do anything.
So at your repo, I'd find instructions for getting it all working then.
Yes, we can look at that. Where is the button to make it happen? First, we need a new browser window, so you don't have to see all my terrible tabs, which are probably full of like bad things and piracy. And then I'll get to jail, and then they'll pit me in like a fight, and like I have to watch my best friend's brain getting beaten out. That happened in like a TV series once.
Okay, what am I seeing? How you files?
Screen share the.
What do you show us for how to set up hardware for it?
There we go. Can you see my Epic browser window here?
Yep, I see it.
Let's make it a bit larger. Let's pick the Neo Humor. That's one I think has the better documentation. Blah blah blah.
Good.
Usage. It tells you how to get your SD card set up. Basically, you need your Neo EPO bin. You need your thing. Then it tells you how the ROM fix tool works, which the games of the scrambling need.
Nice.
They're scrambling. They need the ROM fix because unscrambling it at load time would take like forever. Because all the addresses are like scrambled around, so you can't just load it in a big block.
Right, so you got USB controller compatibility.
Oh yeah, that's very limited.
Yeah, what about, do you have a recommendation for what hooks up to which ports? How are you setting up your hardware?
Where the hardware setting up, that's in a very funny file. It's called config.spin2.
Okay.
So what you have up here is you have direct boot. You can just define this to skip past the menu if you want. That's the thing. This will use JP BIOS, will change whether it defaults to the international or Japanese BIOS. Then you have to define one of these, which is select the memory type, 16-bit PSRAM, 8-bit PSRAM, 4-bit PSRAM, HyperRAM. Hyperram is new. I've actually added support for that.
Nice.
It doesn't run. It runs like a handful of good games, but like the really good ones start like 24 megabyte or something, and Hyperram board is 16 megabytes, so cool. Then you have selection about where the PS RAM goes. It's pre-set up for the P2 Edge.
Okay.
Then you have a bunch of other stuff that's also pre-set up for the P2 Edge. Is that even the correct setting? I don't remember. Is this async clock sync data? Brain hurt, I don't know. That's the
Okay, so that's a
configuration for Hyperram. Then you have this, which is a bit of a mess. This is all of the video modes that you can have. That technically just I've kind of got example configurations for all of them commented out, except for the VGA. All you really need is
so we need the VGA adapter.
No, you can use anything really. It's, as you can say, it supports VGA 3X. You can also say VGA 2X. I think this should be sub modes instead of actual modes. Maybe I'd have to refactor that at some point.
What I'm trying to get to is, am I running this on a Johnny Mac? Am I running it on a Mini Edge? If so, which adapters am I running with?
You can run it on anything as long as it has the correct thing. And if it's not, you can hack it. But yeah, this is running on. I've only tested it on an eval and Johnny Mac with the RAM Edge. I don't think plugging a RAM board into the Johnny Mac will work at all because the traces are too long.
Okay.
Or if it works, it will be terrible. Just don't do it.
The Mini Edge would support the Hyperram, but the Johnny Mac won't.
I don't have the Mini Edge. I can't tell you about that one. But it would take up 2 slots on it. It takes the Hyperram board takes up 2 slots, so maybe it would just be 2. I don't think you'd have enough left over to actually put all the other stuff on. So that's kind of a bizarre question.
Now you're getting to my point. What is all the stuff that needs to be put on?
The
DVI.
again, you don't need anything really. You can configure it for all sorts of things. But I guess the recommended setup would be the VGA output board, USB output board, and then you just need some sort of memory and some sort of SD card.
Okay.
But some sort of SD card to just
the
it needs the SD card.
The 32 meg Edge is probably a good choice because that
the 32 meg Edge has memory on it and it's nice and fast and reliable. It's not the biggest, but it's decently large.
Right. So what I don't see at your repo is kind of show us the hardware you're using and how do we recreate that hardware. That's
that's kind of missing. The thing is, I've written it to you can just reconfigure it for anything. Like if you don't want the VGA board, you can just use the DVI board. You still need something to put the audio.
But if I know an example set of hardware that works, then I can start from there and have the easiest setup time.
Yeah, I should probably tell it that probably add to the README what it's pre-configured for.
Yeah.
Like what happens when you just compile without anything. And maybe I should change the default to VGA 2X because some people say have problems with the 3X mode.
Yeah, really, I would go to your repo. I'd expect to see a list of hardware add-ons you're using the P2 eval.
I'm using either a P2 eval or a Johnny Mac. I have both. But,
right. So I would expect to see the P2 eval, the list of hardware boards that connect to the connectors and where you put them. And then if I could replicate that, this should just download, compile, and run.
Well, it doesn't use a normal build system anyways. You have to use you have to use the build sh because it uses whatever this does.
Yeah, cool. Okay.
It used the epic.each-h. What do you think that -e.h -e-h does?
It generates images for specific locations would be my guess.
Exactly. This generates compiles a spin file, so it will run when it's loaded to this address. And that's kind of the trick. I need all the low memory, and I need it have it in a pure pattern file, so I can like align things to like 64K boundaries and stuff like that.
Makes good sense.
And that's what I use this feature for, and that's why it will never compile with anything else. Also note that it needs a second blob for the input, because this upper blob actually gets deleted once the game launches.
Nice. Nice.
And this one stays resident.
Right. So yeah, that all makes sense. And so then just knowing what the hardware is to give me the least amount of time to set it up. If I have all the hardware pieces, I just need to know what it is.
Yeah, it doesn't say it anything up here. It just says here configure video audio input RAM in config bin 2. The comments hopefully, and there's a RAM config MD for
Can
all
you
of this.
Can you put up a picture annotated with how your setup looks?
I mean, I go between like different setups. I plug it in differently all the time. That's kind of the problem. We don't really have a board that you can just write for and don't have to think too much.
Mm-hmm.
But we would buy that thing again. It's a cat eats mouse. No, it's a mouse eats mouse. It's something eats something. The chicken eats the egg. No, that's wrong. The pig eats the egg. Yes. They're known to do that, especially if they're round and green.
What the heck? My Zoom window just got amazingly tiny and I can't move it.
Just happens.
That was weird.
Anyways, this is the support list. It looks like this. It tells you how much memory you need for each game. That's very useful. Sort of rounded up to the nearest sensible size. So for example, if you for some reason want to play, let's close my eyes and pick a random one, Pop and Bounce, you just need the 8 megabyte, which pretty much everything provides.
Mm-hmm.
If you wanted, no, it's just a different one. If you want to play, this is broken anyways. If you want to play King of Fighters 2002, you need 96 megabytes. There's no way around it.
Mm-hmm. Mm-hmm.
I think the smallest one, the smallest unit that I have here is 4 megabyte. Can we find a 4 megabyte one? I know we had one just on the menu, but there we go. League Bowling works with half a PS RAM chip. Sadly, the actual smaller capacity PS RAM chips are a quarter of the size. We don't have anything that works with just 2 megabytes. It'd be very pointless, but you could do it. You could not set up a setup with multiple banks of the 2 megabyte chips because it doesn't work for that. Just don't, please not. But for the 8 megabyte chips, of course, that's how the 96 megabyte board works. It just has 2 in parallel for the 8-bit bus, and then it just has 6 banks of them. Do we have a picture of it? Probably somewhere, but
Okay. Well, thanks.
We can also look at what the Mega Human does. I haven't checked that one as much, and I made that one first, so it's a bit more scrimblo and brimblo. Also, give me more stars on my GitHub. If you don't, I will come to your house and I don't know, paint stars on the wall. This one has 3 stars. By whom there's a couple dudes. Even the Electro dude. Who is such a dude that is in his username. Where's the config for this one? This one doesn't have a support list, and for some reason the README is a text file instead of a markdown file. My brain exploded at some point when I realized that. Why did I do that? I don't know. You have the same RAM config in D. It's basically the same. It just tells you different good config for the P2 Edge because, of course, the config's not portable. It tells you the 96 megabyte board doesn't work because it's too slow. I've had support for that for NeoHuman, so the 96 megabyte board doesn't actually work at like the full speed that the P2 can do because it has too many banks and it like gets all scrambled up because of the like long traces. But if you make it slower, it works. And I was too lazy to implement that into Mega Humor because the 24 megabyte add-on board, that one is reliable and good.
Ada,
And yeah.
When you're done explaining that, can you say what you did to improve the YPBR, PBPR coefficients?
Oh, that. I could just look at that right now. Well, first off, I had to realize that for some reason these were in like reverse order in the CICQ registers. So I was always having PB and PR swapped.
Oh,
That was one thing. And the other thing was just recalculating the constants down here.
okay.
This is what they look like.
Okay, good.
And it's not, I don't think it's quite perfect yet. I think part of the issue is just that these 8 bits aren't quite enough resolution,
Right.
but it's good enough, whatever.
So of all these different RAM possibilities, does the one on the P2 Edge module with the 4 chips, does that performance is about as good as it gets, right?
Yeah, that's basically best performance. It has very low delay. Of course, it has the 16-bit bandwidth, and it works at full speed. So
Okay.
that's just about as good as it gets. The only downside to it is that that you can't make a bigger one. It's fixed at 32 megabyte.
Right. Well, if we took another 16 pins, that would be a lot. We could talk to more that way, right?
No, you just need another chip select pin.
Oh, would that help?
Yeah, you just need one chip select pin, then you can have a second bank.
Right,
Not sure
so-
if it works as fast then though, because there's issues when you add banks up. 2 might be alright. You may have to increment delay one. This is all kind of
Right, there's this
fiddly-bobbly,
tri-stating issue.
fiddly-bobbly. No, there isn't. I mean, this 96 megabyte board has the same chips on it. It has 6 banks. As said, it's an add-on board for the eval, and it has like terrible routing, so it doesn't work at full speed. But there's no tri-stating issues. It just works.
Well, okay, gotcha.
I mean, I've had this running over like multiple days. With
Right.
like everything is like overclocked and everything, and it's like the hot summer. Like it doesn't get any hotter. Not in this basement, mind you, but I guess this is the hottest it gets in the basement.
Right. Okay. Oh, so you've added a lot of stuff to this. Hey, now the code that runs the 4 chips on the P2 Edge with the 32 megabytes, is it does it have to handle like multi-clock delays, or so that you have to time to receive the data, so that you're a variable number of clocks after you toggle the clock pin?
The value is technically variable, but since it's always the same, it's just hard coded. It just ends up being hard coded.
Okay, so it ended up being hard coded, which is good.
Yeah, this is just the PSM delay value here, and that's the sync clock sync data. By the way, none of the P2 documentation mentions what psync IO means. You have to just know it from the back of your head what it means. It's not documented anywhere.
Oh, did I not? Let's see. It is in the Silicon doc, right?
Nope.
Well, hold on.
Nope.
Let me show you. Okay, this is.
It might just say it might just say that it's there, but it doesn't say what it's actually doing.
Wait, sync
Maybe.
clock or sync data?
That's just the constants that I use. I mean the
Those are
psync
yours.
IO bit. I mean the psync IO pin config. That one's.
Okay, because you're talking about something that resolves to a bit in the low-level smart pin control, right?
Yeah, and as far as I know, that's not
It enables
documented
the
anywhere.
clocking. It enables the clocking. Okay, well, look, I think it's covered here. Let's see.
I have to end my sharing.
Okay, let's see here. The difference is between this and this, right?
Yeah, I guess that it kind of documents it, but like who understands this?
Right.
Like this might. First off, you have to make the connection from the fact that what the psync IO does to this,
Right.
and then you have to understand what this actually translates to, which is I think it actually like removes like a half step of delay, which is kind of bizarre.
Oh no, what did I do? Hey Jeff, are you still there?
Yeah, I'm still here.
I just did this thing that I did once before where now I've got some image at the top of every page. I don't even know what I did.
La, 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 da, ba.
You know how to get out of
You're
this?
broken.
Double click on that. There's some strange behavior of
Wait,
Google
maybe I can
Docs
just do a Control Z to get out of it. Okay, there we go. All right.
yeah, oh yeah, that looks like it fixed it.
Yeah, sometimes I've had this problem where it suddenly like sucks up some image and puts it at the header of every single page. And it's
Yep,
very confusing.
I've had the same deal, and Control Z was my friend because I've never found what causes it.
Okay, the way I've described the psync.io in my memconfig file is it says this is a sort of half step backwards for the delay value, which I guess is what it does. Does it mean? I think that is what it does empirically, but I don't even know what's going on down there. You just set it until it until it stops corrupting, and then you never touch it again. And if it fails again, then you sacrifice like a virgin to the blood gods.
Kind of right there, but that doesn't elaborate much.
Yeah, it doesn't ever tell you what it does in practice, which is
yeah. So what it
the
does,
delay around.
It engages some registers within the 3.3 volt pad circuitry, and
yeah, I know what it does on the thing side, but it doesn't. I know what it does empirically. I know what it does on the circuit, but no one else knows because it's not documented.
Right. So do you find it's helpful to do one thing or another in that PS RAM driver? Does it help to select that or not?
Yeah, as I said, it's basically like a half step for the delay value.
Okay.
It has, when reading, it has to do like delay compensation, and that's in entire steps of cycles. But where you adjust the sampling point where you want to sample the data, but setting the sync mode for the data pins is a sort of half step.
Okay.
Setting the sync mode for the clock pin does something as well, but I don't know what it does exactly. Sometimes it does things, sometimes it doesn't.
All right.
If it doesn't do it, you sacrifice the virgin to the blood gods. I've said that.
Okay. Hey, while you guys were, Ada, while you were talking about your emulator, I went over and worked on this thing. And so I added a break button. So you can say debug main, blah, 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 blah. If you turn everything off, then it becomes the break condition, right? So if I select any of these things and then I select break, so break is the absence of all sensitivities, so that when you run now, it will require you, it'll make it so that only the break button, the async break, will get you out of that. Does that make sense to you guys? So break is the absence of everything except for this. Init is independent because we can always detect that. But anyway, so when you run like this, now if I had both of these on, it would break on a cog init, but those don't happen often. So break.
Oh, that's an interesting one in the chat. Someone asks, how do I type the @ symbol on the Swedish keyboard? Because apparently it's on like a key that's a hotkey in Propeller tool.
The X?
The @ sign. Guy says it's on Alt Graph 2.
Oh, you mean the $sign?
No, the @ sign.
Circle A.
Oh, at.
So Shift 2 doesn't. Is Shift 2
It's probably Alt Graph 2. Like on my German layout, Alt Graph 2 is the squared symbol. I can see what happens if I set my thing to Swedish, because I can. Let's just do that.
The at. I knew a woman who thought it was actually the cat symbol, because if you look at the A with the circle around it, does kind of look like a cat. It at least looks like C and
Okay.
F together.
So let's see what happens in a good program, basically Notepad++. We have to actually enable it because no, this is still set to Japanese. That's bad. Okay, I can confirm Alt-Graph 2 in Swedish is @. And what happens if I put this into Propeller tool? Yep, it just creates a new file. Epic. I think that may be an issue worth fixing. I mean, the obvious solution to this is obvious workaround to this is to just use a different keyboard layout. But then you have to then again, who wants to type Alt-Graph 2 to type the @ symbol? That's even more obnoxious than Alt-Graph Q, which on the German layout @ sign is on Alt-Graph Q, which is almost as obnoxious, but that's not the top row obnoxious,
So are you saying on that layout, Shift 2 is mapped to something else?
No, it's Alt-Graph 2. You know what the Alt-Graph key is, right?
No.
I've heard of it.
Americans.
We're so
Oh,
ignorant. Please
the
enlighten
idiot
us.
Americans does not understand the European good invention, like European invention of the Alt-Graph key. It's the key that's to the right of the spacebar, and it's, I think, basically just Control and Alt at the same time. I think. Yeah, it's just Control Alt at the same time, basically.
Okay, so Control Alt 2 is starting a new file instead of putting the @ sign in.
Yeah, that's something that probably.
So it's like Alt F new or something.
No, it's Control Alt 2 is an intentional shortcut that it has to start a file from a template. So if you
Oh, this is that Propeller tool has.
yeah.
Okay.
We're taking over a shortcut
Yeah.
that is actually a normally used character.
Yeah, in fact,
Oh.
that was added for the P2 support to open up a P2 template
Does it
automatically.
sound like you should pick a different character for that then, so we can stay away from something that would be used?
I think all Control Alt characters might alias to an Alt-Graph thing. You might be able to. I'm not sure if it is possible to detect whether you're actually pressing Alt-Graph or you're pressing Control Alt. I think it must be, but I'm not entirely sure.
Yeah, if I could detect which one it is, then I could avoid that. But I'll have to look into that.
Yeah, get a keyboard with an Alt-Graph key. Or does it just equivalent to the left Alt? Does it have the same scan code as the right Alt on a US keyboard? Is it the same scan code? Who knows?
We don't know.
Wait, is there even a right Alt?
Yes, generally, yes. There's a left and a right.
Okay, good.
Yes, and you can detect, or they generate different codes.
Yeah, we don't have right Alt. We have Alt-Graph. It is usually written as Alt-Gr. Because for some reason at some point the German keyboard actually had like half of its keys translated. Escape is still ESC, but Control is Strk. And instead of insert we have Einfk, and instead of print we have Drucken, which is boring. But instead of pause break we have Pause Unterbr. And instead of home we have Pause 1. Okay. We have Ende. We have End for delete. And we have build up and build down.
All those
course,
noises, all those guttural noises you're making when pronouncing those sounds remind me of something I heard history teacher say once that Voltaire thought that German was a language fit only for soldiers and horses.
I mean, that's something you probably do come to a conclusion that you probably come to if you just listen to it without understanding it.
Oh, I know. Of course it makes sense. I think he spoke French, right? So the French are very, very proud of their own language.
The French. The French need to have their own extra boost. Always.
Right. Stephen,
Yes, sir.
on the motor control stuff, you found that it was still overflowing even after some of our conversations, but it was going like high because it was actually getting negative or above the positive range. But you got that clamped in to range now, right?
Yeah, basically what I found was that we were being over aggressive on driving the motor as we're speeding up. At the lowest level driver, we were driving the Cordic math, a little bit out of range. As soon as I changed the upper limit for how fast we can drive it, we can still drive it as high as we want to, but now in single increments, we're going to limit how fast we go. We no longer drive out of range. And now the PWM is completely stable all the way through until we can't until the motor's not responding fast enough to be controlled mechanically.
Okay, that's good. So you're getting higher RPM out of the same motors than you were. Because we
Correct.
could not figure out what the trouble is. Because on our visual scope display, everything always looked fine. But the trouble is we had this algorithm that was like looking for the highest and the lowest and then averaging them and then adding that to every.
Right. You were running an artificial sine wave for ramping your motor.
Yeah.
And basically ramping up to a reasonable high and then ramping down to a reasonable low and back up again.
It would look like
that
this.
kept you right. That curve kept you out of the error behavior, the flawed behavior. When I was trying to characterize what's the top end I can do for any motor at any given power, let's say 18.5 volts, what can I do? What can I do with that motor? I was running up to fault and backing off again, and then working my way ever closer to finding out where that fault boundary is. The fault boundary, however, was also induced by this PWM breakage. And so what my algorithms were doing was seeing where it would run up until where the PWM was broken, not to where the motor couldn't be driven. And so I was actually choosing an artificial low speed point, because our PWM stuff was broken. As soon as I fixed that, and now I try to find how fast can I go before fault, now I'm actually running up to where the motor just can't keep up to what we're trying to do. And so my top end limits now are real. And I can show you what it looks like. I have a table at my repo, which can show you what we're doing for the 4K motor. I haven't gone back and recharacterized the 6.5-inch wheel yet. I'm my own worst enemy there because I mounted them on a robotic platform and now they're a little bit harder to get to. So anyway.
How much higher were you able to go in terms of RPM?
From 2,600 to 3,300.
Okay.
So it was a significant difference.
Yeah, that's like
on the 4K motor.
All right.
So let's see what I can do here. Which table is going to best show what I want, and then I'll share a screen. Oh my gosh. Let's wander around with the mouse on my website. Putting it behind the Zoom window. I shouldn't have to. Okay. Yeah, I have a motor choice page out at my repo that I can, that I'll display here if I can find it, which looks like, I guess this one. Share. Where the heck is the window? My sharing is paused. Why? Because it can't find the web page I'm trying to show. There we go. All right, can you see this table?
Yep.
These are the two motors. So we have the 6.5-inch motor, and then we have the new 4K RPM motor. Here's what I was able to do in characterization at the different voltages. So we can, so Hull ticks per second, right? And then the max RPM. And forward and reverse are pretty much symmetrical. Once I can do a rate forward, I can also do that rate backwards. And so you can see that for some reason the motor has sweet spots at 11 volts
So
and 22 volts. I'm able to get higher RPMs.
well, but you, oh, okay. These are the RPM limits. Okay.
We're correct. And so if basically I can run at this RPM pretty reliably without faulting. And of course, everything lower than that.
Okay, good. They're symmetrical. If we had the offsets wrong, they'd be asymmetrical. You know, those
Correct.
drive offsets.
Correct. And so what I'm doing is I'm running the drive offsets 180 degrees out. And what I am finding is for the Doco motor, though, the offsets are generally around 50 degrees. And for the 6.5-inch motor, it's, I don't remember correctly, but I think it's more like 10, 12, somewhere around there. And so I want to go back and recharacterize the 6.5-inch motor again. I have it mounted with a mini breakout and I need more spigots to do the motor characterization. And so I'm going to have to remount one of the wheels just so I can do this. But anyway, this was a significant change. 3,600 RPM of our reputed 4,000. So not bad.
So they're saying, okay, so is that in line with the spec on the motor?
It's pretty close because if I do one of the people who play with one of the YouTubers who plays with BLDC motors has a chart out there, a spreadsheet that you fill in. And one of the things he does is he takes the drill, runs the motor, and looks at the EMF generated at a certain frequency, and then calculates what the top end would be. And I'm within tens of what the top end calculated is.
Well, you know
him-
what? Why
from
are we
his-
getting higher speeds at lower voltages?
Isn't that interesting?
Are you sure?
I'd like to know that. I'd like to know that too.
Makes me think we're not doing something right, because the higher the voltage, the more juice you can put into that thing. But maybe we're combating like electrical fields that don't want to change that rapidly.
Yeah,
Higher
we have,
voltage.
I think what this table shows us, if we've got some good research opportunities to find out why this is happening.
And we
I
should
would
be
have
able to-
expected, I would have expected a linear progression, somewhat linear towards the higher voltages, and that's not what we're seeing.
No, we might.
Anybody here have experience with anybody on the forum today have experience with BLDC motors? Enrique, have you played with these at all? He's maybe not here. But yeah, I'm still contemplating getting commercial ESC to see what it will do.
Because we're still way below 4K RPM at 24 volts. I mean, what's the secret?
Yeah,
I
agreed.
guess I've always felt like there's something not right about something we're doing with this. I don't think it's our hardware, because our hardware just does what everybody else's hardware does, right? It just PWMs, from ground to whatever the power voltage is.
I would think so.
Could it be that maybe we need to like really lower the PWM rate? Maybe that's our problem.
Well, I've been playing with it. I see no significant difference at 22 kilohertz versus 44. The motor is much happier at 44 versus anything higher in terms of energy output.
So it doesn't like higher frequencies. So I'm thinking maybe lower frequencies where you leave it on longer.
Yeah, people say to run these things anywhere from 20 to 100 kilohertz. But they also suggest that it's very dependent on the physical motor in terms of how it's going to behave.
Yeah.
And they also suggest that there's no, I'd have to go back to my notes, but it was something like there's no way to tell from a given motor, or there's no formula for calculating it for a given motor. Something like that. What the best PWM would be.
Hey, there's just something so weird going on here. I mean, we're still 1/3 away almost from where we should be at the top end.
On the 24 volt, yeah.
Yeah.
You'd think at 24 volt, we could get max performance out of the motor. So something's interfering. And of course, it's interesting that we see at 22 and 11, basically half and double the voltage, that those are our high performance voltage, highest performing voltages.
Yeah, why would that matter?
Right. So, for a 24 volt rated motor,
Stephen,
that's probably a clue to something. But what?
Henry?
Stephen, did you ask it a question? I was looking for information from a new concept of Toshiba, current sensing inside the GaN transistors. So I was distracted searching in the internet for the link.
Oh,
And
okay.
I heard your question, but I don't understood it.
Okay. Yeah, no, Enrique, at this point, I'm just making observations. This set of information right here is me driving the motor to the best performance I can at a given voltage, and then recording what I was able to achieve. And so, so this is the Doco Engineering motor, the new small one. It's rated for 24 volts and 4K RPM. I think the high point is something like 6,800 RPM, not sustained. Here is the motor itself, a description of the motor. Sorry, wrong one. This one. You notice it has fewer Hall cycles than our 6.5 inch motor. So it's a much coarser control system than the 6.5. But it's supposed to be able to go up to 4,000 RPM, and we're seeing that despite our really good hardware now, we can't get there with how we're driving it.
Yeah, there's just something there's something going on we're not getting a handle on.
Correct. And so this is now at 44 kilohertz PWM frequency, and very well synchronized. So we're looking for what effects could this be at this point.
Did you scope the waveforms to see any distortions caused by a mismatch into the positioning of the poles of the motor in relationship with the sensors or the current?
I was seeing some oddities at these at 22 and 24 volts. There's a typo. At 22 and 24 volts, the motor would tend to reflect. We're down at the lower voltages, the Hall effect sensors are providing really uniform shapes. Up at the higher voltages, the Hall effect sensors are less uniform. And initially, I thought that was because of our bad PWM. And once I fixed the PWM, I've been moving so fast just to get the code out there that I didn't go back and really characterize the shapes of those Hall waveforms again. I should go capture those at the different voltages. Lower RPMs look fine, higher RPMs, they tend to get erratic. And so the question is, I think, Chip, you were theorizing that this is our fields overwhelming the sensors. And, we need to find out. All we have is hypotheses at this point. Well, we don't know what to go after or what to disprove.
For you. Hello?
Go ahead.
Oh, I believe that you are limited in a certain sense because you are using the same.
You dropped out. We're using the same. We lost him.
Unlately, Chip, I think you've been recording for like over 2 hours now.
Okay, one thing I want to talk about just to get in here.
Mm-hmm.
Stephen, is there anything more to say about the motor stuff for now?
small differences due to the fastest or not driving capacity of the gates in relationship to the current waveforms.
Interesting. Enrique, you dropped out for quite a bit of that. You have my email, don't you? So
I don't, please speak slowly because I'm partially deaf
oh,
from
sorry.
my left ear.
Okay. If you have my email address, you were talking and it dropped out, but I would like to hear what you're saying. Maybe you could send me an email and I'll respond that way.
Okay, I don't have your email, or if I have, I did forget. So,
I'll send it to you in chat.
okay. While we are talking about it, I will forward to you a link about a new concept from Toshiba
Nice.
that spares the use of a sensing resistor. They are putting the sensing inside the transistors, the GAN FETs.
Interesting.
So there is no interference at the grounding of the, they sense the voltage drop inside the GAN FET. So it's a characteristic of the silicon or the gallium arsenide substrate, and does not need to cause any difference in grounding potential of the transistor.
Interesting.
It's a new concept they developed. I was looking for Toshiba because they are having many problems, structural problems, if they will split in many companies or if they will keep as a whole thing. But then I found that link, and it seems to be very interesting to. Okay, I have now your email that I saved.
Okay. Good. Okay, I'm looking at the page. Chip, I put the link to the page Enrique was talking about in chat.
Oh, great. Okay.
So it's just another location at where they were doing current sensing. Anyway, so in fact, you're looking at the page. I didn't realize I did that, Chip, all of you. Sorry. Let's see here. Is there anything else? No, the new release of the motor driver is better in that it's better at detecting low RPMs. The sensor code is reworked, and it's also now better at going faster with motors. And so everybody has access to that code now. I wanted to get that released as quick as it could. We probably got more characterization to do now, of course, but at least you all have it. So that's all I have for motors.
All right, that sounds good. I noticed in there they show an inductor after the totem pole switch,
Right.
after the half bridge, and I wonder. I mean, that kind of makes sense, right? That would convert that AC into more of an average DC. Because we have that in the motor, but I don't think we really want the inductance in the motor. It'd be better to, because every one of those windings is like some kind of coil with resonance and a complex impedance. So maybe putting the inductor on the outside before the motor would help quite a bit. But it seems to me that the windings in the motors are going to be bigger inductors than what you could possibly practically locate before you connect.
Chip.
Yeah.
Otto, you might want to mute your Mike there?
Oh, sorry.
Thank you. Go ahead, Enrique.
In this driver board, you are using a single point of sensing current. So it's hard because you cannot note faster small differences introduced by the three coils individually. You need to do a lot of effort in filtering the current waveform just to be sure you are having the right measurement. But it's every time you increase the precision of the whole detection, you lose precision from the individual waveforms. So that's why it's my belief. That's why many circuits use single current sensors, one in series with each winding. So they can observe the response of the windings and gather more data about the behavior of the motor as is it's driven by the transistors.
Right.
In a certain sense, a single point of measurement is good when you have a low precision in the detection of current. But when you can have high precision, it's my point of view. I'm not a specialist. ERNA seems to be a better source of information in that point. ERNA is one, I believe he is a professor in Switzerland or something. And I see many systems that have individual current sensing per induction coil, per coil. So it's easier for them to spot, including small differences in the placement of the magnets. Because you can spot by the reiterated positioning of each of the coils in front of each magnet, if one or two of them are out of alignment, magnetical alignment. And then you can correct your drive so as to have the smoother rotation possible.
Okay. Do you
This
think
is
putting...
my noob point of view.
Okay.
I believe, because I ever remember Erna mentioning what you can't see rotating the motor. I believe it was him that stated that. What you can't see by rotating the motor with your hand or with, says, a rotating tool without driving, you cannot see this. What you can't see that way, you will not see when you are driving the motor.
Okay. I wonder if putting like a little inductor, like it shows in that link, and a little inductor before you get to the motor, if that would help turn those high frequency pulses more into a steady voltage. Because if we run that signal directly into the motor without any inductance like we do now, then we're causing those motor windings to sing quite a bit. And I wonder, you know, if they kind of like resolve to a appropriate field, or does all that disturbance cause them to not develop the net magnetic field that's needed to operate them very well?
You are talking of something like a snubber.
Yeah. Yep, yeah, because I'm kind of wondering, like, why do we have all this voltage? We have this circuit, but we can't come within like 26% of the motor's top speed at the rated voltage. There's something wrong. But you know what? It would be easy to fix that. We could mount those coils onto where we hook the motor in. It wouldn't need any circuit board modification because it just goes on the leads to the motor. You know, Stephen, maybe we should get some, I don't know, like really high current, you know, good for like 40 amps or something, some kinds of inductors to run in line with each of those.
You need to use inductors whose core material is
Yeah.
able to deal with the waveforms, the speed, not the frequency of the signal you are passing through.
Yeah, like
Because
a choke.
if the core material is not of the right permeability, it will not respond as you want. It's the same occurs with the motor. When you have a bad motor, a bad constructed motor, I always
Uh-oh,
We lost him.
he'll be back, I think.
Net
I'm gonna
drop.
look on on inductor. I'm gonna see maybe what we could do is just
Yeah.
order if
Tip,
they
you're
have
still
any-
recording. You haven't stopped it yet.
Yeah, well, I still haven't talked about the ADC board.
Right.
That'll take just a minute.
one rotary switch. You can craft a rotary switch with one of the motors, and they are very, very precise. I don't know if the motors you are trying have at least the same percentage of stability when you compare one coil with the other and in the positioning of the magnets.
Look at those, Steve. Those are like $11 and there's like 20 of them.
Right.
They're good for 6 amps. That's just the first thing that popped up. But that, if we put those in series with each wire, maybe that would. Oh no, here's a better one. Actually, this is a better one. This is a 20 amp,
Better.
50 microhenry. And you get 5 of them for $13. I'm going to order some of these.
Yeah.
And just to try them out, because maybe this will solve our problem. Something's not right. Okay, I just ordered a set of those things.
Sweet. Okay, let me know, and then as soon as you decide you like them, I'll do the same.
Okay, yeah, I'll try them out because I've got everything here to do that with. And but that's what we need, is some real power, you know, inductor to kind of just smooth things out. Oh no, that's interesting. They have like,
Of each one.
they have
Each
4
inductor.
conductors.
Well,
Look
yeah,
at they're
what's,
just double wound.
what's with the taps there? Oh, double wound. Okay.
I think we just group them together, right?
Don't know.
Anyway, we'll all see. We'll
Not
see
a question for me. I'm not the one.
We'll see if that does it. All right, so let me, I'm going to show
You're playing with a
thing
new
we've
board,
been
are you?
working on here. So we have had in the past, you guys have seen this thing here. Let me get this. This is the headphone adapter, right?
Okay.
So it's just, we gang 4 pins for left, 4 pins for right, and we run them through a couple of caps, a film cap for the higher frequencies and a big polymer electrolytic for the bass.
Okay.
And then they run to a headphone jack, which is this thing down here. So this, we built some of these and they work really great. You know, if you have like high quality headphones that are like 30 ohm impedance, these things are fantastic. And they can play really loud, louder than you'd want to have on your ears. So the other thing that we need to complement that is a high quality ADC. So we were going to use a part from the same company, but it was a little bit simpler in some ways. But DigiKey said they had like 370 in stock, but it turns out they had 0 in stock. So they have some more of these. So we've got these things on order. Apparently they're in inventory. And this is a 4-channel, 192 kilohertz, 32-bit ADC. These are like $7. And they're like 107 dB dynamic range. So this, for doing real audio stuff, this is way better than using the ADCs built into the chip because it's just not up to hi-fi standards at all. But this should be pretty good. And it's funny that you look at these signals, the way they arrange is, see you have analog input 1 plus analog input 1A minus. It's like plus and minus. And you actually like run both plus and minus through caps. One cap will go to ground and the other cap goes to your signal. And then they have some microphone biasing circuits. So we're going to have the board set up so that you can run 2 line ins and you can do 2 microphone ins to get all 4 channels. And you could have all 4 as line ins if you want, by not turning on the microphone power source, which is all inside. It's configured over I²C. But once you configure this thing with the I²C, then you just run the clocks and the framing signals, and it just does these 32-bit conversions at 192 kilohertz and sends you all this data out on 2 different pins. One is for the stereo set of A, and the other's for the stereo set of B. So we'll reel in 2 sets of data. But anyway, this should give us super high quality audio A to D, so that for people that are interested in doing hi-fi or musical instrument stuff, this will be like a suitable platform. And of course, the headphone board can also be used as an output. You know, I mean, as a line out. You don't have to just plug headphones in. It just happens to be very low impedance, so it can drive headphones also. So Michael, we got this resolved. The last of this detail resolved this morning. So he's going to lay these boards out, and it will probably sell them as a set, you know, for headphone or audio out and mic and line in both stereo. That was the last thing I wanted to talk about. And I can turn off the recording now.
Nice.
Let's see
It'll be
here.
fun.
Any questions on this, by the way?
One thing. Did you observe the problem Ada was having when she connected her headphone? I believe.
Sure.
Yes.
I know what you're talking about.
Yes, I believe you need to put some kind of protection, not only in the headphones out, but even into the line in or microphone in, because of the length of the cables. Because I bet someone will soon be using it on stage. And the wireless, even if they use those 3 wireless adapters that I powered, they can use the line out for those preamplifiers and connect you to the prop. So you have a huge installation with many chances of ground loops and perhaps no protection into the inputs or the outputs of those boards.
Yeah, that's a thing. I think it happens when I plug the whole thing into my computer, and then I plug in headphones. It actually crashes.
With headphones, it actually what?
If you have, so I haven't really looked into this because I don't know, I don't care. But when I had the P2 eval hooked up to my TV, and it's very cool 120 volt ground. Yes, the ground is 120 volt AC. Don't question it. It happens when you have too many things with just a two prong power thing. If you have a lot of those connected together, your ground level just becomes more and more spicy.
Oh yeah, yeah.
And then it has to, and then I connect it to the P2 eval, which is connected to the PC, which has proper ground, so it actually syncs all that garbage through the P2, and that I think is what makes it crash when I plug in headphones for some reason, because I don't know how that works, but it doesn't crash when I just have the P2 eval hooked to the PC. I don't know how that works, but I did manage to sometimes crash the P2 eval. And by crash, I mean it probably has something to do with the memory, because it just like hangs on a static screen. So it's not like the P2 is dying entirely, because then it would also, the screen would collapse because the video dies. But no, it seems to kill all the actual thing that's going with the emulator. I haven't really looked into that further because I don't care. I don't know. Sometimes you just have to let the issue be and don't think about it too much.
Mhm. Well, we'll see. We'll build it, and this thing has. It wants you to connect the analog grounds to the VSS one here. We can do that, and then after we get that tight network, then we can route that over to the digital ground. You know, it's
Also, have we figured out why why there's so much noise on the, especially on the P2 eval, why it's so noisy when you have anything happening? The audio on the AV board gets like incredibly noisy.
yeah. I don't know. I mean, I think it would be ground noise. I think because ground is used to convey, you know, half of every signal. So
Yeah.
it's
Interestingly, if I have the headphones plugged in, it doesn't happen. The only thing that I'm not sure, it doesn't happen as much, I don't think.
oh really? If the
Part of
headphones
the
are plugged
reason
in?
maybe, yeah, it only happens through the line in.
Maybe you're lowering the impedance, or maybe you have to have a low enough impedance signal going in that it overrides the noise that's being injected on the P2
Yeah, the
side.
line in, of course, on the PC is like high impedance.
Right.
So maybe that's it.
This thing I was
Another
looking-
thing I'm thinking maybe it, because sometimes you just get noise in a line in from other things. It may just be that the audio input has like the same ground or the same power as the USB, and maybe some other I/O stuff. So maybe it's just that the computer sucks.
maybe.
And I mean, it's not the cheapest motherboard. It's a weird motherboard, which how many motherboards do you know that have an AM4 CPU socket and next to that like an old style PCI card slot?
Yeah.
They exist like a handful, but it's like bizarre, right? And I actually use that PCI card slot. I don't know why exactly I got it. I did not get it for the PCI card slot. I don't even know how I got to this, but I have it, and I will never swap it out because they probably don't make them anymore. I mean, you can probably get used ones or like new old stock of the same one, but they like don't make ones with new chipsets probably. Not that I care, because the new chipsets probably don't work with reasonable versions of Windows. And then all the software, of course, in the future will stop working. It already does, kind of. And then I don't know what I'm doing. Yeah, I don't know what I'm doing when like a major software starts not working on Windows 7, because I don't know. I don't like upgrading things to, especially when the quote unquote upgrade makes it worse.
Right. Yeah. That's the modern experience.
it should be illegal to make an update for software. It makes it worse. Like you should actually go to jail if someone like depends on your software to update it to be worse. Of course, no one will actually go to jail because then they'll get like really paranoid about making sure that doesn't happen.
Maybe.
I mean, technically, no one should go to jail because unless they're like a completely insane person who like just wants to stab people, they should probably go to jail. But I don't know, jail bad, especially if it's like in America where they like make money off of it somehow. Like all meat has to be turned into a profit somehow. Like
Are
Like-
you still recording, Chip?
Yeah, let me turn, I can return the recording off. Hold on here. Just a minute. Let's see. Recording, here we go. Okay, I'm gonna stop the recording.